Hello, everybody, and welcome to my talk today. It's going to be called Why Dots is Unity's Silver Bullet. So, anyways, just a real quick introduction into myself. So, my name is Johnny Thompson, and I'm a fully independent Unity developer. So, I do a lot of contracting and consulting type work. While that I talk about Unity a lot, no, I don't work for Unity. I am fully independent and all that. And yeah, many people may know me from my Turbo Makes Games YouTube channel where I do a lot of dots related stuff. So I'll put up a lot of tutorials on there, as well as showcase videos where I just, make cool things with Unity dots and kind of, share them all with the community. And then more recently, within basically this year, we started doing a live stream with a couple friends of mine. It's called the Hot Path Show, and we do it every Friday. And we talk about basically solving problems in game development using data-oriented design. Now, because the three co-hosts for that show, we all are very familiar with Unity and Unity dots and all that. That's a lot of the topics that we talk about on that show. However, we have started to kind of like get into other kind of like data-oriented programming languages and talking about how they can be used for game development as well. So anyways, I'm just going to give a real quick introduction to this talk. Again, it's called Why Dots is Unity's Silver Bullet. So in this talk, I'm just going to be going over, kind of like what is dots, the importance of dots, why I think it's really cool and all that. And then later we're going to be talking a little bit about the future of Unity dots, because Unity has recently kind of announced that they're kind of, having this like kind of ECS for all initiative, where ECS is going to be kind of like the backbone of a lot of parts of the game engine. There's a lot of really exciting stuff with that. So yeah, I think this is going to be a fun talk and ready to get into it. So first off, we'll start off with what is data-oriented design. And I'm just going to be doing kind of like a high-level overview about, what is data-oriented design and introduction to ECS and all that. But if you do want a little bit more of an in-depth introduction to data-oriented design, actually last year at the JetBrains GameDev Day, I did a talk, and you can actually scan the QR code right here to see the YouTube replay of that talk, where it was just a little bit more in-depth introduction into, the concepts of data-oriented design. And, it's just kind of giving like an introduction into, what writing ECS code looks like and all that. So it is just a good kind of introduction if you do want a little bit more information on data-oriented design. So real quick, just at a very high level, data-oriented design, the way that I kind of typically define this is by saying, data-oriented design is when you're making architectural decisions in your application based on how the computer will best store and process this application data. And so it's really important to know that, the solutions are specific to your problem. So, each problem that you come across in your game, you really want to kind of, analyze that and determine, what is going to be the best solution. A lot of times it is going to be, how can I make this run the most efficiently, structuring my data and processing and everything like that. But then, other times it might be, okay, maybe this doesn't need to be as efficient, but I can make it, more convenient for me in some other ways. So it really is just kind of like, looking at every problem as individual things and not like, using a turnkey solution for everything, but, just really kind of testing things out, getting good metrics, and, solving the specific problems that are right in front of you. So a couple ways that you can kind of approach this data-oriented design is structuring your data to avoid cache misses. So a lot of times in object-oriented programming, as we have, all these different objects that, maybe inherit from different classes or, reference different objects and everything like this, we're going to end up going to have a bunch of objects kind of, scattered out through our memory. And, it just ends up being quite inefficient as we try to, access a bunch of these different things. We're constantly having to go to different places in memory, and most often that memory is unfortunately not going to be stored within the CPU cache. So we're going to have to, go out to main memory, which can be a lot slower to access, as opposed to something like data-oriented design. We might want to structure our data in a way where data that we're going to be accessing very frequently, together, is going to be stored contiguously in memory, so that, as we're accessing things, it's more likely to be within the CPU cache, which just leads to really fast and efficient processing of that. Another thing with data-oriented design is we're kind of wanting to, avoid these complex inheritance structures. There's a couple of reasons for that. One is just kind of, like I said, the memory layout of all, if we have all these, different objects that inherit from other objects and having subclasses and everything like that. And, all along the way from all these different classes, we're getting, different properties and methods. Again, as we're kind of like, accessing those different things just in that one class, again, we're going to be having to bounce around, a bunch of different places in memory. And then, personally, from kind of like a readability standpoint, I just don't prefer having these inheritance structures where, we might have to be jumping around a bunch of different class files to follow kind of, like one logical path of something. It just, I don't like that structure. I'm going to be showing kind of like, some other ways in data-oriented design that, I kind of prefer structurally. So now we can kind of move towards some more Unity specific topics. So what is DOTS? So DOTS is a Unity concept. It basically stands for their data oriented technology stack. So DOTS is an acronym. And it really is just a collection of Unity packages that are built off of these principles of data oriented design. So some of the main packages that you'll come across are the entities package, also known as ECS. This is kind of the core, I'd say, most important package when it comes to Unity Dots. And basically, this is kind of the entity component system. We're going to be going into a little bit of detail on what this is in just a second here. But really, it is kind of the core structure of how you typically want to structure a Dots application within Unity. Now, I should mention that all these packages are pretty much interchangeable. So if you're, quote, using Dots, you don't necessarily have to be using Unity ECS. You could use some of the other features that I'm going to be mentioning in just a moment here. However, they all are kind of intended to work together. And when you're using all of them, they work together really nicely. And you're able to kind of, take advantages of all the different packages, when you're using the most amount of them. Another really important package is the jobs package, also known as the C# job system. And this essentially enables multi-threading within Unity. Now, typically when you create a Unity application, most of your game code is just going to be running on the main thread. And this ends up, being a little bit of a problem when you're starting to do, more complex logic. We have maybe more dynamic entities, or maybe they're doing really heavy calculations and all this. And that's going to end up kind of really just taking up a lot of resources on the main thread. And now your main thread is like, kind of having to wait for some of that work to complete before proceeding. With the C# job system, we're able to actually schedule some of that work onto, some of the worker threads on our machine, because, nowadays we have PCs and consoles that have, many threads and cores available to us. So, it's like, why not take advantage of that and be able to kind of, offload some of that work onto some of the other threads. Another very important one is the burst compiler. Now, the burst compiler basically takes, all this high-level C# code that we write and compiles it down into really fast and efficient assembly code. It does a lot of really nice optimizations as far as, SIMD, or single instruction multiple data, which basically means, maybe we have multiple bits of data, and we can kind of like, pack those all into just one single instruction call to process those, which just ends up being really fast and efficient. And the burst compiler is actually pretty easy to use, especially, again, if we're using, the entity component system and job system. These other packages kind of have some restrictions that we need to follow, and same thing with the burst compiler. And as long as we're kind of, following those restrictions, it's pretty easy to just, enable the burst compiler, and we pretty much instantly get at least 10x performance boost from the burst compiler. So it's really amazing stuff. There are some other Dots packages that I do want to mention. So there is a physics package, again, all based off of data-oriented design principles. And also there is a version of the Havoc physics package that is kind of, built off of Dots as well, that is available. There is an entities graphics package, and that's kind of used for rendering entities within the ECS world. There are a couple limitations of this right now, unfortunately, but they are kind of working towards getting it to full feature parity with just regular Unity rendering technology. There is a mathematics library that is compatible with the burst compiler. So a lot of these, math functions are, just basic things that you would find in like the mathf library as well. However, they just work a lot better with the burst compiler and can, compile down to really fast and efficient machine code. There also is netcode for entities, and Unity seems to really be pushing this netcode for entities as a way to, have kind of, more ambitious and competitive type games built in Unity, because these data-oriented principles, again, are kind of geared towards fast and efficient gameplay. And so, it has a lot of benefits for, doing competitive multiplayer games. And there's, netcode rollback and different prediction algorithms and things like that. So it just really leads to a better player experience for competitive type games. And actually on my YouTube channel, I did create a big netcode for entities tutorial, just kind of like, walking you through creating a full game with netcode for entities. Again, yeah, it's just available on my YouTube channel. So dots right now, it is still fairly separate from Unity game objects and mono behaviors, but they are kind of working to close that gap a little bit. So there are, some tools that we have available to us, like manage data components, or this new thing called Unity Object Ref, that basically allows us to, reference game object and mono behaviors from the ECS side. However, it can be still a little bit cumbersome to work with, which is a little bit unfortunate. However, in the future, Unity has stated that they're kind of having this whole entities for all initiative, and they're kind of unifying the transform system so that game objects and entities will both kind of run off of this same unified transform system. And I'm going to be showing a little bit of that, kind of towards the end of the presentation here. But it is really exciting that Unity is kind of working towards getting it kind of a little bit more integrated in the engine, because right now it still feels like something that's a little bit separate. Whereas, when we kind of want to interact with some of the existing Unity features, it's definitely doable, but sometimes it's just not necessarily the cleanest way. So here we can talk a little bit more about, ECS. So ECS itself is just kind of, a concept that's actually been around for decades, and Unity kind of has this entities package, which is essentially an entity component system, or ECS. So when we talk about the entity component system, well, it's actually a separation of three different things. So we have entities, components, and systems. So the first one that we want to talk about is an entity. So an entity is really just a thing within our game. So this could be, a player character, this could be a vehicle, or this could be something, a little bit more, it doesn't necessarily have to be something that's rendered in the world. This could be, some kind of more high level game logic. Now this is a little bit misleading because, really an entity, it's not actually anything. All an entity really is an index. Now, this is kind of like an oversimplification of how it actually works. But basically, we can think of, when we start having like all these data components, just data associated with these different entities, these are going to be just stored in like big arrays of data. And this entity is really just an index into those different arrays. Now, because the way that things are structured, they're kind of going to be structured in parallel arrays. So basically, if we key into any array at a specific index, we know that that data is all going to be associated with one single entity. So again, an entity, it really isn't anything, but it's just kind of like an index saying, hey, this index and all these different arrays, let's kind of like, associate that together to be, one kind of thing within our game. Now, when we talk about data, again, we're talking about data-oriented design. So data is really kind of like at the center of all this. So, we have these things called components, which is the second part of ECS. And this is actually where we store all of our data. So in this case, we have this thing called an iComponent data interface. And, that's basically what Unity ECS says, hey, this struct is, a data component that we can use within ECS. And you can see that these components are really just containers for data here. We're not doing any, there's no methods or functionality. This is just kind of the raw data. Again, these are the things that are going to be stored in those arrays that we key into. When want to associate something with a specific entity. Now, for example, in this case, we have, say, some like enemy attack properties. Now, we can think of this as maybe some data that's not going to change throughout the life cycle of our application, where we kind of have, a number of hit points where, how strong the attack is going to be. And we also have a cooldown of, how long the enemy has to wait between the different attacks. And then maybe we also have, say, a separate data component, and this can be some kind of like value that changes. So, for example, we have this enemy attack cooldown timer. So, anytime that an enemy attacks, maybe we can reset this value to this cooldown timer value here. And then we can kind of have some systems that actually, decrement that attack timer so the enemy knows when they can attack again. So kind of speaking of systems, we can kind of move into the last portion of this, which is the systems. And this is actually what operates on that data. Now, these systems are really cool because basically we can just say, find me anything with these, specific sets of components, and let's go ahead and just operate on that data. So you can see in this case, we just have a little bit of a character move system where we do this thing called an entity query, where we can basically just say, again, find me every entity with this specific makeup of components. So in this case, we have a local transform, a character move direction, and a character move speed. And then you can see on this line here, we're basically just, applying that transformation, just a pretty basic transformation here. So again, these systems kind of, work on these groups of data. And there's kind of some really good efficiency gains, which we'll be talking about in just a second here. But for a second, I do just kind of want to talk about composition over inheritance, because this is kind of like, one of the core concepts of ECS. So, for example, if we're looking at inheritance from, say, like an object-oriented programming perspective, we can say like, oh, okay, we have this, Toyota Camry within our game. Now, this Camry, it might inherit from a sedan class, and that sedan class inherits from a car class, and that inherits from some vehicle class, and that all inherits from object. And again, we kind of have this whole, big inheritance structure where we have, all these, different things. And again, along the way, we kind of are like, getting all the different properties of, sedan and car and vehicle and everything like that. And so, again, we're kind of like, getting access to data and functionality as we kind of like inherit from all these different classes. Now, to contrast that with data-oriented design, we do kind of more of a composition model where instead of saying, inheriting from, all these different types of objects, let's go ahead and say, we'll just create something, and this thing has a motor, this thing has wheels, this thing has, some amount of doors, this thing has some amount of seats. And we're just kind of like, adding these, essentially data components to this one thing. And then basically from that, we kind of end up getting the same functionality result. We're kind of, building up to the same car, but the way that we get there is a little bit different. And, kind of one of the advantages of that is now we can say, we don't really care that something is a car. We don't have to like, specifically define anything in our code that says, oh, hey, this is, a Toyota Camry, or, this is a car. We're really just kind of, adding these little building blocks to this entity. And then from that, we can, again, use these systems to run that processing logic across that data. So yeah, real quickly, I do just kind of want to talk about, kind of like, entity querying and kind of, go into this a little bit more. So, for example, we can say that we have some amount of entities within our game. So we have, say, an entity with a transform component, a move speed, hit points, and player inputs. Well, in this case, this is going to be, say, a player entity. We can also have something very similar that has, the same first three components, transform, move speed, and hit points. But in this case, this has an enemy AI component as well. Now, for this, maybe we have, some amount of entities within enemies within our game. And then, finally, we have something that's a little bit more basic that just has transform and hit points. And these can be kind of, environment elements within our game. So maybe we have some rocks and trees and walls. And again, like we're never specifically defining anything that says, this is a rock, this is a tree, this is a wall. we're just kind of, adding the necessary components to get that functionality within our game. And then, kind of, from that, we can kind of get these essentially different behaviors here. So let's talk a little bit about, doing some entity queries on these operations. So, basically we can say, let's find everything with a transform and a move speed component. Well, in that case, that's going to return all of our players and all of our enemies, because all of those both have those transform and move speed components. And it's going to be ignoring all of our environment elements because those don't need to move. So maybe if we're, want to do some logic to, move everything within our game during, one particular update step, we can kind of look for all those and apply those transformations. Now let's say we get everything that have hit points. Now in this case, everything has hit points. So, maybe we want to, kind of apply some damage to everything within our game. We could do that this way. Or maybe if, say, the player wants to, damage other things, then we can say, let's ignore anything that has this player input component. So, we can say, get all these enemies and trees and everything like this. So it ends up being really nice to, be able to query different groups of things very quickly and efficiently. Another thing that I do just want to kind of bring up real quick is getting into kind of some of the memory layout aspects of it. So in Unity ECS, they kind of have this concept of chunks. Now, a chunk is basically just a 16 kilobyte block of memory that kind of, pre-allocates all this data for us when we, so for example, if we say, spawn our first enemy, in this case, the first time that we spawn an enemy, the computer is going to basically set aside one of these 16 kilobyte blocks of memory called an entity chunk. And it's basically going to, set aside data for enough entities to fit within that 16 kilobyte block of memory. So even though we're instantiating just one, it's still going to allocate that whole 16 kilobyte block of memory. Now, when we want to add more enemies to our system, that memory is already, pre-allocated for us. So we don't have to allocate new memory. All we're really doing is just setting the data on this. So for example, we spawn 3 enemies. We can just go ahead and set the specific data for, the transform, move speed, hit points, AI, and all that. And then we still have room later on when we want to spawn more enemies that, all this data is kind of blocked off already for them. And then, basically, we're just setting the data values on those. And again, you can kind of see like what I was talking about a little earlier when I'm saying that an entity is really just an index. So we can think of all these different, data components as like a linear array. So this is, the transform array, and this is the move speed array. And then when we have these different enemy entities, again, we're really just indexing into those arrays at that specific point to, get that data for that specific entity. So it ends up being, quite fast and efficient to, again, operate on groups of this data, as well as, just find that data in general. So I know we're kind of getting a little bit into the weeds here, but let me just take a step back and we can just talk a little bit about, who should actually use Unity ECS, or even just ECS in general. So there's 2 kind of broad categories that I'd like to talk about. So one are performance critical applications, and the other is games with dynamic architecture. So going into some performance critical applications, a lot of times we see this for games with large numbers of dynamic entities. So for example, we have, say, real-time strategy type games where, maybe we have lots of these dynamic units who are all, needing to do some complex pathfinding logic, and they're going to, need to navigate around all these environment elements and do some targeting to, find enemies within a range. And then, all these, enemies from different groups, they can battle each other. So there ends up being a lot of stuff going on. And, we can kind of use some of the advantages of ECS to, process all these dynamic entities. Another example of a game like this would be something like, management games, tycoon games, city builders, things like this, where, maybe we have a lot of people, and these people all kind of have their own, different goals and desires and things that they do within the world. And then we also have, maybe buildings or roller coasters or things like this that, kind of have some of their own properties, and maybe they're kind of, occasionally doing logic to, for like certain events to happen, or, in the case of Roller Coaster Tycoon, where, having all these, roller coasters go around and everything like that. So there ends up being, again, a lot of dynamic entities, a lot of kind of, simulation logic happening within the background. So this is something that would be a really good candidate for Unity ECS. And then also, I think an interesting example are like some puzzle games. So there was this game that came out last year called Humanity, where you basically are controlling this like giant crowd, and you're kind of like directing them through these puzzles. And it actually is a super interesting game. I would recommend checking it out if you haven't, because it ends up leading to some really interesting gameplay when you kind of have this like giant mob of people. And it's like, how does that kind of, how does the people kind of interact with each other as you're kind of navigating through this whole maze, and how does that kind of change the world? And so there's a lot of like really interesting things that you can do from, say, like a puzzle game perspective. Also, good candidates for ECS are when you're running applications on performance critical devices. So of course, mobile, of course is really big, especially in certain parts of the world. And, this is where performance really, really matters, where, we're kind of typically running our applications on lower end devices that have, limited battery life and things like that. So, there are a couple, of course, this allows us to create kind of, more, exciting and more feature-filled games, on these lower end devices. But also, it just kind of helps our regular games run a little bit better. So that means that, the processor isn't going to be, completely maxed out. We're not going to be, chewing through, battery life. The phone isn't going to be like overheating. So it's really key, I think, in these performance critical devices that, we're being really efficient about how we're processing data. Another example of our performance critical devices are, virtual reality, augmented reality, where, it's a lot of the similar constraints to mobile, except for now it's, strapped right on your face. So if something's overheating, you don't want that to be overheating on somebody's face right there on a, extremely sensitive part of their body. And also there's the whole thing about how we want to have not only a really high frame rate, but we also want a very consistent frame rate. So, as we're kind of, moving our head around, we want to make sure that there's a really good consistent frame rate. Otherwise that can kind of lead to motion sickness. I think another example of a performance critical device would be something like a kiosk, where, a lot of times you see these things in museums where they have like some, tablet or something set up like this. And a lot of times these actually are running Unity applications, just because Unity is really good for, just creating little interactive things. And I was actually at a museum a couple weeks ago, and they had like a little Windows kiosk that was running, just kind of some basic application that's, again, kind of showing some images and maybe some 3D models. But the processor, or the fan on this thing, was just, cranked to the max, just going full speed. And it's like, okay, if that thing's running, all day, every single day, what actually ends up, being the cost, like the energy cost of that, if you're, just constantly running that thing completely maxed out. So, again, maybe these situations where we're having something that's running, constantly, I think that's kind of like a, we want to look at the, performance of our systems. Also, I think non-game applications, there's a lot of really cool things that we can do within these non-game applications. So actually, not too long ago, I had the ability to develop this project called Aviar Graph. And basically, it was kind of took these like Neo4j databases and ingested them into Unity. And then we're actually able to kind of view these graphs in a virtual environment. Now, this ends up being a really kind of performance critical application, because all these, essentially nodes and relationships, they're all kind of, putting physics forces on each of them. So as you kind of, move things around in the application, the graph kind of reacts to that. So This application actually was originally built out using regular Unity game objects, and the performance ends up being pretty capped out at around maybe 100 nodes or so. And again, this needs to work in a virtual reality environment where, again, performance is extremely critical. Now, with Unity Dots, we're able to really ramp this up and get to a place where we were able to simulate graphs with thousands of nodes and relationships. So I think anytime where we have some applications where we need some type of like real-time simulation of things, and maybe we're doing a lot of complex logic, especially across large numbers of dynamic entities. Again, this is a really good candidate for Unity ECS. So yeah, real quick, I just want to talk about why ECS is a good fit for these performance critical applications. So one, like we kind of already mentioned, is the whole data layout aspect. Again, with object-oriented programming, if we have things kind of scattered throughout memory, again, we're going to be having to go out to our main memory to access a lot of that data. So that ends up being very slow. And in some cases, it can actually be 1,000 times slower to access things in main memory as opposed to, some of your caches that are closer to the CPU. And again, with data-oriented design, we're kind of, structuring that data where it's, our like data is going to be stored contiguously in memory so that, when the CPU goes out to memory and it fetches that first bit of data that we're working on, well, it's also going to, prefetch the data that's, comes after that. So that basically means that as we start processing that data, well, the next data that we're going to be needing to process is, just kind of, right there available to us. So that's kind of, again, some of these advantages of structuring these things in arrays and processing things in groups, because we can kind of, take advantage of how the CPU, best wants to, process this data. So it ends up being, very fast for that reason. Another reason, again, is the burst compiler, where we're kind of, compiling things down into this machine code. Actually, what you see right here is the burst inspector. So you can actually see in Unity the, actual output of some of this data that, or the assembly code that gets, compiled down. So for example, I have this, say, player move system, where we're saying, defining a new vector, and you can see that, this is the actual machine code that ends up getting ran. And again, a lot of the stuff is very efficient, uses, single instruction, multiple data, operations on all this. So again, that's another massive speed up in performance. And then finally, the job system, kind of like I mentioned before, we have kind of some logic running on the main thread here, but then we also have all these worker threads down here, and you can see these kind of green sections here are where we're actually, kind of offloading some of that processing across all these worker threads. Now, again, you can see all this stuff is running in parallel, and there's, other things going on in the main thread. So, we're able to, process these things kind of like in parallel in groups. So, again, if we have large numbers of dynamic entities, we can, push off that processing across many of these available worker threads to us. So again, that's another massive efficiency gain for having large numbers of dynamic entities. Then again, I do just want to talk a little bit about games with dynamic architecture. So some games with dynamic architecture are maybe some things like roguelikes, where, for example, we have, this game called Spelunky, where there's a lot of different things within the world. And it's really cool because, all these things are kind of, different concepts, but they still kind of have like a consistent rule set. And, this makes, I think, really interesting gameplay because, basically, if there's any like essentially object in the world, well, we can pick it up. And if there's something that we can pick up, maybe we can also throw it. But each thing maybe has some of its own slight variances. Like, so for example, if we say we're to pick up this crate and throw it on some spikes, well, the crate is going to break open and maybe it's going to, have some things in it that are going to kind of spill out on the ground. Or maybe for example, we have like this brick of gold. And if we were to throw that on some spikes, well, kind of by the architecture in our game, we don't have that break on the spikes. Instead, it just kind of, falls down to the bottom. So again, we can kind of do some interesting things with dynamic architecture here. Another example is a game called V Rising, and they actually did a stream with Unity a little while ago where they kind of were showing some of the technical aspects of their game and how they actually used Unity ECS to do some really interesting and dynamic things in their game. It's quite a long stream, and there's a lot of really interesting things that go into it. So if you're interested, I'd recommend checking that out. Again, this is V Rising by Stunlock Studios. So why is ECS a good fit for games with dynamic architecture? So again, when we have object-oriented programming, the data and transformations essentially live together. So maybe we have this character mono behavior. This kind of has some vectors for the move direction and position, and we kind of have some update loop that's getting player inputs and moving the character, and applying this updates to the position and all this. So again, we have these data and transforms that live together. And of course, I've already talked about some of the inefficiencies of kind of having things structured in kind of a way like this. But in data-oriented design, we can kind of contrast that. So the data and transformations are separate. So maybe we'll have some struct for our move direction, and then we have some system here that says to get the player input, and then we have another system that is kind of like our move system. So things are a little bit more separate. You can see that it ends up being approximately, I'd say, like the same amount of lines of code to create these data transformations as object-oriented programming here. However, you can see that some of the lines end up actually being a little bit longer. We need to kind of define more things. So that's just kind of like one thing to keep in mind. But one of the advantages of kind of having these separate data and transformations and all this is, again, we can kind of like don't necessarily need to define anything specifically. It's more just we're kind of operating on these groups of data. For example, where we have this say get player input system, we're listening for keyboard input from player, and we're setting this move direction and then applying it in the move system. Well, maybe if we have some enemies, we can say, have some enemy AI system that determines this move direction here. And then, this enemy AI system, or the enemies can also take advantage of this same move system, because we're in both cases, whether the player or the enemy, we're setting this move direction component here. So again, in this move system, it doesn't matter that we're working with a player or working with an enemy. We can apply this movement in the same manner here. And actually, well, another thing that I wanted to mention real quick on having separate data and transformations is because things are a little bit more separate, it actually ends up being a little bit easier to kind of test things out, because things are a little bit more isolated. We can kind of test things just as they are, and we don't end up having this whole nasty web of kind of like dependencies, or maybe it's a little bit more difficult to test. And then also, I think refactoring, it's actually quite easy to do, because things are so separate. We can literally just, if we wanted to make a different move system, we could just say completely disable this move system, and we'll create a brand new move system. And as long as we're operating with the proper data components that our entities have, then we're able to create new systems with new behavior. And that's been one of the major advantages for me, that when I've worked professionally on projects that use ECS, is that I've done major refactorings on some of these core systems, and I was able to just kind of rip something out pretty easily, add something in, and again, I'm not having to untangle this whole nasty web of dependencies, which has been really nice. Okay, so another thing that's really cool is we kind of have control over system state. So for example, if we were like making a game where we kind of have maybe some kind of like narrative section or some exploration section where we still want the player to be able to walk around within the world, and they're kind of searching for things, but again, it's kind of like a narrative scene. Maybe we have these two characters who are like talking to each other. Maybe just kind of like for the mood of our game, we don't want to enable combat here, because we don't want Nathan Drake to just start like attacking Elena for no reason in this scenario. So we can kind of control the the combat systems, where we can just say, let's turn off all the combat systems within this one section, And then, we don't have to like, keep a list of, who are all the, characters within the game that can like attack each other. Okay, we need to like, go on to all these entities and, change some state on those specific entities. And then now we need to, remember to re-enable that when we want to re-enable combat. Well, again, we can just do this more at the system level where we could say, hey, this section of the game, let's just disable those combat systems. But we still want to keep, all the movement and exploration, interaction systems enabled. And then, when we get to a point where we come up on some bad guys, let's go ahead and re-enable the combat systems. And then, all the entities that have the ability to participate in these combat systems can just, start using combat if they want. Okay, so real quickly, I'd just like to give a quick demo in Unity here, kind of demonstrating some of the advantages of this composition over inheritance that I think leads to really cool modular architecture here. So what I have here is just a little thing running in Unity. You can see that we have this little green character that we can move around, and it can shoot off some attacks out into the world. Now, these attacks don't really do anything. You can see that they're just kind of, moving through these other enemies here, and they're kind of just like going off into the distance. So let's kind of like go to these attacks and, add some functionality to them here. So for example, we see this, I've called it a capability. And so here we have a projectile speed. And if we want, we can, really ramp up this projectile speed. Of course, this data is, fully editable to us. So, now when we shoot them off, the attacks are going much faster out into the world. But we'll just go ahead and leave this at 7.5 for now. And so let's go ahead and add a new component here. So we'll go ahead and add the damage on collision. So in this case, we're just adding a new component that says, now when we collide with one of these entities, we're going to apply 10 points of damage to them. So we come over here, and then now we can shoot this off, and then we can see that these guys are now taking 10 points of damage. We have some little damage pop-ups that are kind of going there. So let's say next, maybe in this game, we want this to be kind of like more of a cannonball or something. We don't want it to like, pass through these enemies. Maybe it hits the enemy and then we'll just kind of destroy that. So we can say, go ahead and add a destroy on collision. And then now this kind of gives us the ability to basically kind of destroy this on collision. So we'll go ahead and collide with one of these enemies, and you can see that it no longer kind of goes through, it just collides with the first one here. Now we can do some other interesting things. So maybe, for example, we want to say, spawn something when it gets destroyed. So, for example, we can go ahead and spawn an explosion. In this case, so now when I shoot this, it's going to go ahead and actually spawn this explosion. This explosion will kind of now damage some entities in the surrounding area. And that's because I've created this explosion to also have some of these similar scripts that damages the other enemies when it collides with them. So it's kind of built off of the same thing that this initial projectile was built off of. And then of course we can remove components. So for example, say we don't want to have this projectile speed on here. Maybe we want to make something that's kind of like more of like a landmine. So for example, now I can press that, and then it just kind of spawns that off into the world. And actually, I forgot to add one thing on here. So we want to actually add a destroy on timer as well. So this will actually destroy after, we'll say 5 seconds. So now we can come back here, and now we can add a landmine. So we can go ahead and do that. And then after 5 seconds, this should explode. And then that again applies damage to the surrounding enemies there. So yeah, you can see that we kind of have like, again, we never like define something specific where it's like, oh, this is a fireball, this is a cannonball, this is a landmine. No, we kind of just like created these little building blocks, and now like our designers can go in and they can create, whatever different types of behavior that they want. Again, without specifically defining things, we just kind of have these little building blocks that we're using to, add up to create these new and different behaviors. And of course, we're just doing this within the editor here, but there's no reason that we can't say, expose that to our players to have some maybe big skill tree of, different things to, upgrade our different attacks where, our attacks are starting to get more capabilities or they're getting more powerful, we can definitely do that as well. So there's a lot of really cool things that we can do, with these kind of modular dynamic architecture of this game. And those are honestly kind of some of the things that excite me the most about using Unity ECS. So I'd just like to go ahead and kind of talk a little bit about the current state of Unity Dots and then kind of go into some of the future of Unity Dots as we kind of close things out a little bit here. So the current state of Dots here, what I like about it, of course, there is a lot that I like about it. I think I've kind of shown some of the things throughout the presentation here. But I really just prefer the ECS and data-oriented design architecture for the performance and modularity. So of course the performance stuff is really cool. Again, it allows us to make interesting games that we weren't necessarily able to before. Just because, again, all these performance, again, all these specific things that kind of Unity provides us. Where we can get these like really big performance numbers. I think this unlocks kind of more interesting gameplay that we weren't necessarily able to create before. And then again, the modularity is something that I personally like. There's kind of some cool things that I've created with that little combat system that I kind of demonstrated, and some other things along that nature. That I really just prefer the ECS workflow. And frankly, as I've gone on and maybe worked on some other game object based projects, I really find myself missing a lot of the features in Unity ECS. It's like, it would be really nice if I could just kind of like query for all these entities and just kind of do some operations on those. There's definitely things that I end up missing when I'm developing more game object based projects. Now, it's definitely not perfect. There still are certainly some issues and limitations. So for example, is definitely missing some features like UI and animations. And, I think for something like UI, this isn't necessarily something that needs to be ECS based. However, in our games, we definitely need UI to, kind of inform the player about what's going on within our game. And right now it ends up being a little bit cumbersome about, how we kind of have to send data over to our UI. And then if we have some, UI events, how do we kind of, make things happen back on the ECS side? So there ends up still kind of being that split between, entities and game objects. And, again, all this stuff is completely doable, but sometimes when I'm doing this, I'm just like, oh, this is really not ideal the way that I have to do this. Another big thing is animations. So right now, there's nothing really like built into Unity that's, this is how you do animations with Unity ECS. Right now, again, the way that you kind of have to do that is maybe use some game objects or, do some other limited approaches. I will mention that there are some solutions that are available on the Unity Asset Store and some other animation libraries that people have created kind of as like a little bit of a stopgap. Unity is working on their own solution. We'll talk about that in just a second here, but again, that still is a little bit of a limitation. And again, a lot of these limitations kind of have to deal with linking things on the entity side and the game object side. And, like I mentioned a few times, that ends up just getting messy. Unity has given us some tools where, we have this thing called like a Unity object ref, where we can, reference, just regular mono behaviors, things like transforms or UI sliders or, really any kind of Unity object type thing. And, there are kind of some cool things that we can do with this Unity object ref, and it is definitely a nice feature. But again, it just ends up being a little bit messy when we actually want to, kind of use it. And again, send things back and forth between essentially the two sides, because there still is a decent split between the two right now. I will say that it also can be a lot of code for simple mechanics. The project that I just showcased where, I had all these, different combat things and we're kind of, building up these capabilities and all this. It ends up being kind of like a lot of code, a lot of like just like setup code to get to that kind of like starting point where we have all these building blocks, that our designers can kind of use. Because again, for each of these, aspects that I'm kind of adding to these different attacks, well, I have to create like a new data component, and I have to create a new system that, processes all that data. And so it ends up being a fairly large volume of code, just to create kind of like, simple mechanics, especially, this is really apparent when you're like creating something like a game jam or just, prototyping something out. You have to do a lot of setup code to get to the point where you're like, actually testing out your, features for the first time. So it's not necessarily ideal for prototyping. Of course, unless you're like, prototyping something that's like, really core to ECS, and it's important that you're using ECS. However, I think that stuff kind of ends up evening out a little bit over time, just because, once you have these building blocks in place, you can kind of reuse a lot of that code to, again, create new behaviors with it. So, I think in the long term of a project, the volume of code kind of evens out with a regular object-oriented based project. Another cool thing that Unity is doing is they take a lot of advantage of source code generation. So here, for example, we have a character move system. And you can see that it ends up being just a pretty simple thing here. We have an update method. And then again, we have this kind of like for each statement where we're iterating through everything, this transform, character move direction, character move speed. And you can see it's pretty simple how we're just kind of applying this data here. Now, this is actually not the code that's running. Again, Unity takes advantage of source generation, and actually within JetBrains Writer, we can inspect that source code. So you can see that there's this little thing that says dots right here. And if we click on that, it comes up with this little menu, and this says show generated source code. So if we click on this, we can actually see the source code that gets generated, from kind of these different operations. Now this ends up being quite a bit of code. So just this short little system right here, this actually generates into about 175 lines of code. Now, not all of that is like, actual code. Like you can see a lot of this stuff right here is we have this like hashtag line 198. And this is kind of an interesting thing that Unity does to, basically map the code that it's running to the code that you wrote. So this actually ends up being kind of like a very helpful for debugging. So, when some, particular line that fails again on the code that's actually running, the debugger can basically look at this, little line attribute above that, and it points to the place in your code that, the actual error is happening on. So again, even though the code that you're writing is not necessarily the code that's running, you can still see the line that it's erroring out on. So that can be, a little bit confusing, especially if you're kind of newer to some of these ECS concepts. But it is really cool that in Writer we can access this generated code very easily, because there are definitely some times where I want to kind of look at some of this generated code and be like, okay, what is the code that's being generated here, and like is this the most efficient way that I could be going about things, or again, if there's some errors, every once in a while I need to kind of jump into the generated code. For the most part, you don't need to worry about it too much. But again, it's nice to have in those few cases that you do end up needing it. So as we close things out here, let's talk a little bit about the future of Unity Dots. So a lot of the things that I'm going to be mentioning here, Unity basically showed off in their Unity Engine roadmap talk that was at the Unite conference. I would definitely recommend checking out this talk if you haven't already. I think it's about 45 minutes long or so, and they talk about all different types of things, not just dots, but a lot of things on graphics and, other cool things. And, a lot of the stuff in that talk, just really made me be excited about the future of Unity. So anyways, let's talk a little bit about some of the Unity Dots specific things. So one thing that they announced is this kind of ECS for all initiative. So again, what this kind of means, and again, there's still a lot of like, questions about how this is practically going to come into play, because they basically said that this is going to be kind of a major feature of the engine in kind of the next generation of Unity after the current Unity 6 version. So this ECS for all, basically it's a way that a lot of the kind of regular features within the Unity game engine can take advantage of ECS, even if you as a developer don't have any familiarity or experience with Unity ECS, which is really great. We can everyone can kind of take advantages of those performance aspects of it, without having to worry about it. And then, I think one of the things that they kind of mentioned is that like each game object is now also going to have like an entity associated with it that can kind of do some of that more, efficient processing and everything. So that's really exciting to see. And then, they've also kind of said that, if you want to, for the power users, the people who are familiar with Unity ECS, you can kind of essentially dig a layer deeper and then, create some of those systems yourself, or kind of, manually manipulate things on the ECS side. And kind of one things that they showed off is this essentially unified transform system where now we can have game objects and entities live side by side. Because right now in Unity ECS, all these entities are kind of limited to something called a subscene. Now there are a lot of advantages of subscenes, and there's some cool things that you can do with them. However, one of the limitations of them is you can't do cross-scene references between this subscene and the main scene that your game is running in. So for example, if you want to have like a camera follow the player, you can't just drag in the reference of the camera to that entity, because they essentially live in different scenes. So you can't have any kind of cross-scene references like that. So again, that kind of comes back to the point of how it's a little bit annoying to kind of bridge that gap between entities and game objects. We have to come up with different solutions for kind of doing those cross-scene references. But again, in the future, we're going to kind of have this unified transform system where entities can kind of live within the same scene as game objects. So that's going to be really nice to see. And they've also showed off a new animation system, which is really cool. A lot of very exciting features on that. It is compatible with game objects as well as entities. And again, they showed this little scene here where there's like, 1,000 of these knights kind of like storming this castle here. And they're all, skin mesh renderers using the new animation system. And again, it's all built off of Dots Tech. So everything runs, very efficiently, uses ECS, jobs burst, everything like that. And it's also just a really cool animation system. Like, I think there's a lot of features that people are going to like in there. Again, check out the roadmap talk if you want to see some of the things they previewed there. And they also showed off some of these new world building features. So if we want to start creating more, complex and interesting terrains. Again, all this stuff is built off of Dots technology. So we can kind of, really take advantage of the, really, just kind of making more ambitious worlds essentially. So again, a lot of really cool stuff there. Again, this is all built off of Dots tech. So yeah, to kind of close things out a little bit, as you can tell, I definitely am very much a fan of all the data-oriented design concepts that Unity, kind of has given us to this point. And then, I'm just really excited that Unity kind of, continues to see how important this is and kind of use this as kind of a lot of the backings of kind of their game engine, and that more people will be able to take advantage of these technologies. So yeah, I just think there's a lot of really exciting stuff. And again, I think it's really cool that you don't necessarily have to know anything about ECS to take advantages of some of these performance aspects that it gives you. However, if you want to start getting a little bit into the nitty gritty and kind of dig a layer deeper and kind of get into the ECS side, again, all that stuff is absolutely available to you. So again, if any of this stuff sounds interesting to you, I would just recommend, starting to get familiar with it, because it sounds like it's going to be a much more important part of the Unity game engine within the coming years. And yeah, so that's pretty much my talk here. So thank you very much for listening, and thank you very much to JetBrains for having me back on for the Game Dev Day this year.